Welcome back, everybody. Uh, if you're new here, welcome, and if not, welcome back. Today, at the ACM, we will be doing a workshop, an interactive workshop on the machine learning. So, if you guys have done machine learning, this would be a great review for you, and if not, this would be a great introduction to that. So, I sent out a couple of answers in the Discord to suggest you guys bring your laptop. So, I hope you guys have done that so you can follow along. If not, you can still just take notes, kind of follow along, maybe with pencil and paper. So, yeah. So, yeah, again, I suggest you guys work along with me here so that you can all have a copy of the code that you've written, and that way you can kind of build onto it in the future and make potentially your own projects with machine learning. So, highly recommend. Yeah, so I'm gonna go with that in a second. I'm gonna have a little slideshow first, but yeah, Google Colab is the application we're gonna be using today. It's a free online service for developing Python code. So I hope can you guys all see this back there? Okay, kinda. Okay. Um, if you are someone who has trouble seeing at a distance, I'm going to send it closer just because there's going to be code written on the screen. It might be helpful to just keep it closer. But other than that, yeah, so this is a workshop on Python data analytics, specifically in machine learning. So without further ado, I'm just going to get started unless there are any preliminary questions. Okay, awesome. So from here, I've seen the Titanic. Couple hands. Okay, so uh, that is kind of alarming. Yeah, how many people have not seen it? But anyways, it's a good movie. But the Titanic was a disaster involving a cruise ship with thousands of passengers, and that cruise ship sank. And so by the end of today, you are all going to have created a machine learning program that will look at a list of passengers who are on the Titanic and consider different factors about them, such as their gender and age, and whether they were like first class, second class, third class tickets. And you will be able to predict whether or not that person survived the Titanic without actually having that data. So that's going to be the focus of the machine learning project today. So for those of you who don't know, machine learning is just a form of artificial intelligence where computers make predictions about certain pieces of data using something called training data, which is in this case, it'll be a list of, so in this case, it'll be a list of passengers with labels for whether we know they survived or not. And then the testing data will be a list of passengers who we don't know if they survived or not from the Titanic sinking. We'll be trying to predict that. So there's a couple types of machine learning. There is supervised learning, which is what we're doing today. That's the most basic kind, where you feed it a bunch of data with a bunch of labels, and then you give it data that doesn't have labels, and it makes predictions. Unsupervised learning is when you don't have labels. So if I just threw out a bunch of data to a model and it tried to figure out which things are more similar to others for whatever reason, that's unsupervised learning. So if you're familiar with neural networks at all, that's an example of unsupervised learning. And then reinforcement learning is a little different. That is one where the computer makes a decision and then gets positive or negative reinforcement and then moves on from that. But as I said, for today, you're only going to need to know supervised learning, which is the most simple kind. Just feed it data, and then you can do something about it. So more specifically, we're going to be going through a classification model, which is a type of supervised learning that has typically two outcomes. There can also be a multi-class version of classification, but most commonly what's called binary classification, meaning you want to determine whether an object belongs to one of two classes. So, for example, a passenger on the Titanic either survived or did not survive. That's binary, so you can determine one way or another what happened. So now, does anyone think they can recognize the classes in the example of spam detection, like a spam filter? Does anyone want to volunteer for this one? Yeah, exactly. Very simple. Either an email is spam or it is not spam. Uh, Two is spam is like a random. Anyways, movie genre is that binary or multi-class, or what are the classes today?
Multi-class,
Okay, and why is that?
because there's not just two different types of metrics.
Exactly, you could have an accident, community, whatever. You could have a bunch of different classes, but there is a finite number of them to choose from. It's not something called a reason model, which is where you put it like put it on stage. That's the way I put it. Yeah, this is classifying into a set of options. And then a medical diagnosis, that could be interpreted different ways. Does anyone want to volunteer on that one? Yeah. Yeah. Yes, that's what I was going for. Positive or negative. You have the disease or you don't. But you could also have a diagnosis with multiple classes of like what are you diagnosed with. And then digit recognition, I'll just answer that for you guys. That one's multi-class, and you could have numbers like 1 through 10 or 0 through 9, I guess. This 10 is not a single digit. Basically, you just have a model that looks at a digit, tries to figure out what it is based on the picture. All right. So this quantification is usually done through a method called logistic regression, which has a lot of underlying linear algebra and a lot of other stuff. But basically, the idea is that your model predicts some number between 0 and 1 based on how likely that that object belongs to one class or another. And then it just uses a model that converts that into a yes or no answer. So, for example, if you are saying that a value of 1 means that someone survived the Titanic and 0 means they didn't, and you might say that if the value is like 0.7, then it would go to 1, and then you would say that a person likely survived. So that's just an example of how this algebraically works. So now back to the Titanic. As I mentioned earlier, there's a lot of different parameters, different information about the passengers, and we're going to try to figure out, did they survive based on using those factors. So what kind of machine learning model will we use, you think? Like yeah, so binary, and then more specifically classification, I guess more broadly. We're going to be doing classification here. Yes, you went to this already. It's going to be binary classification. They did survive, but they did not. And what kind of classification model should we use here? It's the one I talked about on the last slide. Yeah, so this can be supervised learning. But what's the mathematical model for doing this? Yeah, logistic regression. Okay. So now I'm just going to give you guys a quick explanation of why we're using Python for this. Python is just very popular now. It's one of the most widely used programming languages in the world. It is also the language of choice for data scientists and basically anyone doing machine learning. So I'm sure you're all familiar with ChatGPT. That's written in Python. A lot of other large language models or other sorts of AI models are all written in Python just because it has a lot of features to make it really easy to store and manipulate data. So yeah, that's why we're going to be using Python today. By show of hands, who here has written anything in Python before? Okay, so about half of you. That's good. And if you haven't, don't worry. We'll get to that and we'll walk you through it. So yeah, don't worry about that. And then Jupyter Notebooks. Has anyone here used a Jupyter Notebook before? Okay, not very many of you. If you are a statistics or data science major like Jake here, you probably use that, right? Well, yeah, Colab is like an implementation of a Jupyter Notebook. It's all the same thing. We're going to be doing Google Colab, which is an online platform for writing Python code specifically for data analytics and machine learning. It's like a development environment that breaks up the code into little blocks, like you can see here. You can have little pictures of code, just keep it all organized, and at each step you can kind of see what the results are, so you can debug it easily that way. And so, if you guys are going to follow along, I suggest you now go to this link here. Just go to collab.research.google.com, and that is where you will be able to start coding. So, you can sign up for an account if you don't have one already. I think it's just with your Google account, and then just make a blank notebook document, and then yeah, I'll just give you guys a few minutes to do that. I'll check with you guys. Yeah, so when you get on the collab, click the blue button that says new notebook. Just so you can have a blank starting point, and I'll walk you through what to write from there. Just a bit. Uh, Does anyone need more time? Eating out, setting up the lineups. Everything that you're done, and you have a like collab document now. Okay, a lot of you. Okay, now raise your hand if you need a little more time. Okay. I'll give you guys another minute. Do you guys need help? Or okay, I've heard you to be that's fine. Yes, you're on the default documents. You want to just in the thing to do. Yes, so do you all have a blank notebook up on your screen? Not the welcome one, but just like blank, like it has an empty box of code with nothing in it. Okay, perfect. Uh, okay, so I think that's yeah, this is just a reminder if you guys have done that. I'll get to that at the end of the presentation. Uh till then, where's my okay. So I'm gonna make a new notebook. Okay, here we go. So okay. So what you're gonna do is you're gonna select this first coding box. You can start writing code. We are just gonna start uh by getting the file, like the data set we're gonna use. So if you don't know data set, it's just a big compilation of data sorted into rows and columns that you can use to do anything with machine learning or data science. So we're gonna write import OS that allows you to do file management. Um, then you're gonna run this I'll say what I'll do in a second. Okay, you're gonna write if not os exist, and then in the parentheses in quotes train.csv. So that's a training file. So this is just making sure you don't already have it. So if you run this twice, it's not gonna break your system. And then actually I'm gonna post this block in the Discord just because there's a link over here. So you guys can just copy it from you guys just look in the announcements channel. I'm putting that code in there right now. So is that what there you go. Yeah, indents are okay. If any of you guys have used Java or C++ or anything before, indentation doesn't matter in that, but this is Python. So the number of tabs you do actually does matter. If you do the wrong amount, it'll yell at you and it won't let you run your code. So just make sure that when you're in here, these two lines are indented about the same amount. Okay. And then when you're done writing the code in each block, just press Shift and Enter, and it'll run it. So by running this one, oh, that means it worked. Thanks. Okay, so that means that we are getting the file from GitHub. So I made a little repository that has data set. So by running this, you're just downloading that onto your notebook so you can use it. Sorry. I just want to get your brand right. Oh. I know I still need more time. Yeah.
Workshop is capitalized.
Yeah. Yeah, that's a capital one when you.
How important is like capitalization?
No. Yeah. Prefer in the future if I put like the first like the setup stuff in a template for you guys to copy, just so you don't have to do that next time. Because this isn't really like the bulk of what we're doing today. So I'm also gonna paste the next section of announcements. So uh yeah. I can ping everyone. Shoot. No, I don't think so. Okay. Does anyone else still need this up here? Okay. We're going to the next one. So we're going down here. We're just okay. Anything with this, anything in green here, you don't need to write down. The green is comments, so that doesn't take anything. Um, we're just importing some libraries to help us do this. This is also in the Discord announcements, so feel free to just copy and paste from there if you want, to save you a minute or so. Yeah. What? Is it on? Oh, okay. I just okay. You guys should go in the Discord because I'm just gonna put a lot of code in here and get that set up. Okay. If you if you don't have Discord, just ask someone around you and they can get you the code. But that's that. Okay. Yeah, I should have made template for you guys. Sorry about that. But oh, now it's so small. Yeah. To help, we're just gonna try to speed through. So I recommend you go on the Discord and grab it.
This is the president, so I think I copy all of these.
Yeah, just all of that. You can take all of it's in the Discord and yeah. Is anyone done getting to this point? Okay. Oh, and make sure after every one you run it. Yeah. So when you press Shift Enter, you should have a little check mark here saying that it ran successfully. Does anyone got this top box here? Does anyone need more time for that? Okay, I'm gonna scroll down. Yeah, I don't really. Okay, who needs more time? Raise your hand if you need more time, and I'll. You all got it? Or do we need more time? Are you in the Discord? No, it's just you. When you import the libraries, there's two more. Oh, that's not it. You need to have this. Do you have this sign? It does not matter if they're in different boxes or not. It's kind of helpful display for visualization, but it doesn't matter right now. Uh, yeah, and if you got it figured out, help your friends around you. Pop out, pop up after it. No, not yet. Oh, oh. I didn't just really else. It's like there's one. You ready to move on? All right, moving on. Okay, so here's where it actually gets interesting. So, uh, first of all, we need to create a blank logistic regression model. This is a lot easier than it sounds in coding. As I mentioned earlier, Python makes really everything easy. So this entire complicated concept is just model equals log reg and then parentheses. That's all you need. So now you have a blank logistic regression model. And then make sure to run the code, just make sure it works. If it doesn't work, you probably forgot to import the libraries. So go back and make sure you get those from the Discord or ask someone around you. Yeah. So now we have a set of training data and testing data. So for now, we need to load in the training data to actually train the model. This is just a blank model with nothing in it. So we need to actually put data into it so we can start looking for the relationships. So we're going to model.fit and then in parentheses, capital X underscore train, and then lowercase y underscore train. That's just the convention. I don't know why they do a lowercase y, uppercase x, but that's just the way they did it. And if it works, it should pop up this little box saying logistic regression. No capital S. Yeah, it's a capital X, lowercase y. Why is it important? It's just the convention. That's just what data scientists use. It's how they do the split. Not entirely sure what the point of that is, but yeah. So the training data, the X train is factors like a big matrix made of uh, data like the passenger's age and uh, their gender and what ticket class they are. There's a bunch of other factors, but that's all in the X. And then Y is just sort of vector for the output of that, which is just a list of whether each one survives. So X looks kind of like yeah, like age, gender, that, and so you have columns, and each one is associated with a number. So the data I had you guys put in there earlier, the code was to turn all of this data into numbers. So gender, I don't know which ones it's specified as, but it might be like male is 0, female is 1 or something. So you might have something like that. And then age might be like kind of like that. So this is just what X train looks like as a data structure. This is what's going on in the background. And then Y train is just a list of did they survive or not. So 1 meaning they survived, 0 means they didn't survive. So yeah, and they correspond in pairs. So this first person is 17 years old, male, survived. This person's 26 years old, male, survived. This person is 29, female, did not survive. So that's just how you read it, going along with the data. So yeah, as I said, Python makes stuff really straightforward. Again, just one line of code has all this stuff going on behind it. Okay, so now we need to specify the test data that we're going to be referencing against. So I'm going to write capital X underscore test equals process data from file. And then you're going to do in quotes test.csv and then comma PRED headers. That's short for prediction headers. So make sure to put the underscore in there. Just have it written exactly like this. Do you guys want me to put this in Discord as well, or do you guys got it? All right, I can zoom in. Is that good? Right. I'll just keep it zoomed in for now. Just gonna run that. And then make sure after each box that you run the code just so that it's all that's all been processed. Okay. All right, next line, y underscore prediction or PRED equals model dot predict X test. So what these two lines have done is X test has been defined as basically this, but for all the unknown people. So we have X test equals, we have this like matrix just like this with that has data in it, and then this Y test is just this but blank. There's no data in it. So this is the group of people who we don't know if they survived or not. We know what their age is, their gender, what ticket class they are, all that information. We just don't know, did they survive? So that's what we're going to try to figure out using the patterns that the model will determine from this data where they do have the answer. So our goal is to find this. And that's what we're doing here. We're saying Y prediction is model.predict of X test, meaning using this, what does it think the answers are for each of these? Did person 1 survive or did they not survive? Did person 2 survive or not survive? And so on. Okay, is everyone at this point? Okay, awesome. Scroll down. Okay. Now, just gonna scroll down here. So now we need to get the output data. So we've actually, this line of code here, figured out what the predictions are, and we just need a way to view these predictions in some meaningful way. So we are going to do that by making something called a data frame, which is a data structure from a library called pandas, which is very commonly used for data manipulation in Python. So we're going to say output data equals PD is short for pandas. So then we're going to do this with this is open parentheses and open curly brace, so the squiggly. Make sure you have that. And then we're going to say passenger ID. So that's a unique number corresponding to each passenger. And then we're going to set that to equal the range of 892 to 1310. That's just from the data set. That's the list of passenger numbers that are in the training set. or the testing set, sorry. So the training set is everything from passengers 1 to 892, and this is the remainder of them. So we've portioned off a big chunk of them to be the training. Usually the training up here is about 80% of your data. Test is about 20%. That's a very common split in data science. You'll rarely see anything different. So yeah, pretty standard. And then the next line. So now we just have a list of passenger IDs, but that's not what we're looking for. We're looking for, did they survive? So let's add another component to this data frame. Oh, and we're just saying that survive corresponds to this vector. So just a list of values of did each person survive? And this range, if you don't know, this is in Python syntax. The range function represents a list of numbers in a certain range. So it's actually an array containing every number from 892 to 1310. So we basically have two arrays going on here, where there's one array of the passenger numbers. So just like 892, 893, so on to 1310. And then we have another one of survived, did not survive, and so on. So now we put these together, the same data frame, which if you take in linear algebra, it's basically just a matrix. So we push these together so they're now associated. Passenger 800, passenger 892 survived, passenger 893 did not survive. Now, yes.
Oh, I was going to finish, but I was just gonna ask for the prediction model, are you saying like true or false belief choices for the prediction? Or was it just a binary 1-0 prediction?
Yeah, so it's going to be binary 1-0. So anything in machine learning always works with vectors, matrices, and numbers. So there's never going to be any sort of operations on true or false necessarily. So if you have something that's Boolean like that, that is true or false, you would represent it as 0 and 1. You would never put text into a normal machine learning model unless it's like ChatGPT language model. Yeah, so everything is turned into a number. And then you always work with numbers until you get your final result. Yeah, so that's a good question. Exactly why these numbers. That's just something from the data set. So I went earlier and I looked through the list of these passengers, and it just happened to be that they chose to make the test data file contain that range of passenger IDs, while the training data was everything before that. So that's just from the data set. That's what was appropriate. But these numbers will depend on what data set you're using and what problem you're trying to solve. So does that make sense? Any other questions before we go on to the last step? Okay, last step is to take this data, which is currently being hidden from us, and we want to look at it so we can see what is this? Because currently there's a big data structure hidden somewhere that has all of our answers, and we can't see it. So we just need to run a little command to look at that data and visualize it. So you're going to write output data to CSV. Nope. I don't like this autofill. It's always wrong. So what this is going to do is it's going to create a file in your Google Colab environment called results.csv that has your final results. Then I'll just give you guys a second to do that, and I'll show you how to actually look at that file.
What is index equals false?
Uh, that's just a specification of whether you want it to include the like a numerical index for each one. So if we said yes for that, then it would add indexes like 0, 1, 2, 3, 4, so on. But we just don't need that in this output because we already have ID numbers. So yeah. Give you guys a second to finish that up. Got that? Okay. So now what we're going to do is we're going to zoom out here. Going to go to, no, not this one. Where is it? Yeah, you're going to click this little files button over on the left here. And then you're going to go to results.csv. You're going to double click it to open it up. And that should pop up this little matrix here. I recommend going up to a larger display size. And that lets you go through and see all the predictions. So we've predicted that passenger 892 did not survive, 893 did not, 896 did, and so on. So you can kind of look at that data and figure out what we've guessed here. So this is our model's best guess using all the patterns it found up here, using this association. It just took that pattern, applied it to this, and got some output. So now this information looks kind of interesting on its own, but it doesn't mean that much unless we know how actually accurate this was. So we need to run a little metric to figure out how accurate this is. So what we can do for that is, where's my mouse? Where'd it go? There we go. Can run a little command, accuracy score. Oh, grab A. Then Y train, model that predicts train. Okay. Yes. Correct. There you go. So hopefully you guys should get the same number as I did. I don't know why it would be any different, but this is the accuracy score. So it's a number between 0 and 1, corresponding to how often our model's guesses turn out to be accurate. So if your accuracy was 0, that means you got every single one wrong. If it was 0.5, that means you just flipped the coin. If it was 1, that meant that you got everything correct. And so right here we have 0.789, so that means 78.9% accuracy, meaning that more than 3/4 of the people in this little group here had their survival actually correctly predicted by the model. Yeah. That really depends on the problem you're trying to solve. If you're just doing something for fun, trying to learn machine learning, it doesn't really matter if you have anything particularly high. But if you're trying to, for example, determine whether or not someone has cancer, that's a bit more of a serious application, and maybe you want to look at more of 98, 99%. But for something like this, where you're just kind of estimating what happened, like trying to fill in an arbitrary data set, this is an acceptable value. Yeah.
How do you increase your accuracy score? Do you add more training data?
Yeah, so there's a lot of things you can do to increase your accuracy score. A lot of it has to do with how you process the data to begin with. So for this model, the code I had you guys paste in earlier basically just goes down and turns every column into a number as best as possible. However, there's a lot of other things you can do. For example, if you think that someone's age had a really significant effect, then maybe you would want to input the square of everyone's age. So if someone was 15, that would be 225, like, so that it gets bigger and more dramatically for older people, or you could do something the opposite. But yeah, there's a lot of stuff you can do to manipulate the data you put in based on what factors you think might be more or less important, and then you can kind of go from there. Another thing, another way you can do that for a different problem is maybe if you were analyzing someone's income, maybe it wouldn't be so helpful put the wrong number next to each other, but maybe the logarithm would help. So if someone's making $10,000 a year, that would have a log of 4. If they're making $1 million, it has a log of 6. So that way, there's not a very dramatic difference there, which might throw off the algorithm, especially when it's outliers. Speaking of outliers, that's another thing you can do, is you can go in and manually strike out outliers, which does take a lot of practice for visualizing data and determining when data should be removed. But there might be cases where there's just some piece of data that really breaks the pattern and it throws off the model. So maybe if every person on the Titanic who was under the age of 18 ended up surviving, except one, then that one might throw it off and seem like make the model confused and think there's no correlation there. So if you are able to remove that and identify it beforehand, then you can have it make a more accurate model of what's going on and therefore have better results. So yeah, there's a lot of stuff you can do. A lot of it just has to do with getting a good data set. Sometimes data sets just aren't very helpful. So yeah, a lot of different skills, and there are, I'm sure, entire PhD theses into how you can make a model just a couple percent better. So that's unfortunately something that we cannot cover in its entirety in a 1 hour lecture. But I encourage you guys to go and look through that on your own. Yeah, any other questions? This is the end of the code. So if you guys have questions about what we did today or anything, yeah. Yeah, so that's a good question. Usually when you do an accuracy score, you want to do something with the testing data. However, because this data is taken from a competition on a website called Kaggle, they don't actually give you the correct outputs here. So usually you would want to compare to that, but since we don't have access to that, the best we can do is just apply the accuracy to something where we do have the outputs, because we can't actually figure out how good our model was unless we know some y vector, right? Because we'd have to actually know, like compare prediction, did this person survive, to actually knowing they did, right? So yeah, usually if it's available, you want to use testing for that. Although since this is for a competition, Kaggle is like the introductory one. If you plug this in, it will give you your accuracy score. And when I did it, it was about the same. It was maybe 78.3, so about the same. Did anyone ever here use Kaggle before? Okay, a few of you. Then have you done the competition with the thing? Okay. So Kaggle is a website that hosts data sets and competitions for all things related to machine learning. So if you want to do a project on your own with this, I definitely recommend you look at Kaggle and figure out some sort of problem that you want to try to work on. They give you a bunch of raw data and you can do whatever you want with it. So that's really great. They also have competitions on there, which are these little fun activities where they give you a problem like this to solve, and then you have to make a machine learning model on your own to kind of solve that, submit your answers and see how good they are, how they compare to others. So yeah, if you want to get into this kind of stuff and do more machine learning, Jack definitely recommend. That's Kaggle, KAGGLE.com. So yeah, and this is also a place where you can publish notebooks you make. So what we mean today is called a notebook, often called a Jupyter notebook, spelled with a Y, just because why not? Uh, yeah, this is a very common thing, as I said, in data science. So if you want to publish them or get feedback from other people or see what other people are doing to solve similar problems, Kaggle is a great place to do that. Yeah. Can you explain? You know, yeah, I love. Okay, so he's running about what we did at the beginning of this. Yeah, sorry. This was supposed to be stuff that's just like preliminary, not stuff that was the focus of it. But yeah, I can go into explain this. So this is just how we get the data from a file. So actually, I can show you guys what the file looks like because it's not already prepared to go into a model. So uh, is this it's like the test? Yeah. Let's look at train. Okay. So if you look through this, I don't know. Oh, there we go. Uh, yeah, so this is what the data looks like when you just get it from the website. There's a lot of letters and spaces and all this stuff. And a lot of this can be ignored. For example, their name. Uh, there's no reason that you need to plug their name into this machine learning model, right? Because then you'd have to convert it to a number and get something out of it. But someone's name not really have a correlation with whether they survived or not, right? Unless it does, yeah. Maybe you can write a thesis on that. Yeah. So, but a lot of it is numbers already. So whether they survived or not, conveniently, they give you numbers. But yeah,
From the first column onwards.
Yeah,
Why training is gonna be there first.
yeah, I'll get into that in a second. I'm just giving background of what's going on here. So this is a bunch of data. A lot of these columns we really don't need, and some of them need to be converted into numbers. So, for example, they could have just uh, could have had this column saying no and yes for whether they survived instead of 0 and 1. In which case, we would have to manually go in and correct that because a machine learning model doesn't know what yes or no means, but it does know 0 and 1 because it's just doing math. So, yeah. So this whole section is just clicking through it. Um, so this line here is having the pandas library read the CSV, meaning it takes this file over here and it just turns it into something Python can look at, just a little data structure. And then this next line, it says map lambda x 0 if male, else 1 if female. Basically, that means that it goes and uh, it looks through the uh, the gender list or the sex list here. So it says each one is just male or female, and it just says it just converts them into a number. So I guess you can't see it here, but once it's converted in the code, every reference to male becomes 0, and every reference to female becomes 1. And that's kind of an arbitrary choice if you have to pick some number just so that it can do math on it. Um, this one, this is kind of a lazy way of dealing with missing data. So this line here basically says that if there's some piece of data in your code in your data set that's missing or it's broken or there's something wrong with it, just replace it with a 0. If I was actually trying to do this like super seriously and trying to spend a lot of time on it, trying to get the most accurate model possible, I would probably make this different for each data column. So for example, if it's age and I default people's age to 0 if it's unknown, that's going to throw off the model because it's going to think something weird is happening with a lot of 0-year-olds on here, right? So that's not good. So definitely if you're going to do something on your own, I recommend tailoring it to each column, but that was just kind of a general way to make sure that it doesn't break my code when it runs. Because if I don't do that, there's going to be some missing data, which is kind of a little challenge they throw at you in these things. The data set's never perfect, so you have to do something about that. It's kind of off screen. So here I selected a list of the headers or data columns that I want to use here. And so, of course, I want to know if they survived or not. I want to know the passenger class, their sex, age. I think this one's the variable of how many siblings they had on board at the same time, which is a pretty cool metric. I didn't know they keep track of that, but yeah. And then I don't remember what parch is, but fare is just whether they were first, second, or third class passengers. So maybe there's an assumption that people who are more wealthy may be more likely to survive, or whatever that might be. Yes. Then this line is just saying the prediction headers are everything from this one. So in coding, the first thing in a set is always the zeroth. This is 0, this is 1. Just saying, look at all this. This is everything except whether they survived. This is just loading in more data. And this is what JP was asking about. I'm just splitting the data into the X and Y for training. So X is just everything that is from here and onward. So it's all the stuff is inputted, and Y is just the survived column. Yeah, Y is what we're trying to predict. Yeah, X is the input, Y is the output. So X is the data you're given, Y is the kind of data you're trying to predict. So this is just getting the columns. But
So we're predicting on like all of these types of. We're predicting on like.
So the other way around. So we're given X is like all the stuff from 1 hour. We're having an input of all this data, and then the output is just whether they survive. So that's the output. Yes.
Do you know?
Did you what? Was that one? I heard that part. What was the? Do I know it? Oh, Jack and Rose. Okay. Oh, wait. One sec. You guys want to see if Jack and Rose from the movie were actually in here? Oh, that's a big one.
Everything first is
The alphabetical?
yeah.
Oh. Does anyone know the last name of Jack and Rose from the Titanic?
Yeah, Jack.
No, the last name of the passenger. I think it's real passenger. No, that was the actor. Were those based on real people or those just made up by the you know the names? I don't know. Anyways, you guys are all free to go if you like. Oh yeah. Yeah. Taking a group photo. If you don't want to be in the photo, so now you know time to step outside.
Can I take
Good with that? I know. Cheese. Sweet. You're on. Alright, be careful. See you guys next week. Next week.